Assalamu alaikum everyone, hope you're all fine. Welcome back to my channel. Today in this video, I'll be discussing about the database ERD entity relationship diagram, which is the topic of Computer Science 9618 paper 1 theory fundamental. And this is the continuation of my last videos on databases, in which we have discussed in detail the difference between the file-based and the relational databases. And then we have also discussed the concept of the relational databases in detail. So this is my third video in the continuation of the same topic. And in this video, I'll be discussing the entity relationship diagram, ERDs, which is one very fundamental diagram to represent visually the relationship among the entities. So ERD diagram can be used to document the design of a database. This provides an easily understandable visual representation of how entities in the databases they are related to each other. So in the ERDs now there are, this is basically the diagrammatic representation of the relationship between the entities. In order to understand the relationships, the type of the relationship, you need to watch my last video on it in the discussion of the relationships. So today we are going to have a look on its various type, and we are going to convert them in the ERD form. Okay, so the relationships and their types, there are four types of relationships: one-to-one, one-to-many, many-to-one, and many-to-many. They can be written like one-to-one, one-to-many, many-to-one, and many-to-many. Basically, the relationships, as I have just mentioned, the ERDs, that a fully annotated ER diagram that holds all the information about the relationship that exists for the data is to be stored in the system. And it is a conceptual model. It does not relate to any specific way of implementing a system. If the system is to be implemented, a relational database, the ER diagram has to be converted to the logical model. All right. To do this, we start with a simplified ER diagram that just identified the cardinalities, how the entities they are in connection with each other. Now, as I said, that the relationships, they are either one-to-one, one-to-many, many-to-one, and many-to-many. So basically, relationship 1, 2, 3, these four type of relationships are here. I've just mentioned it. Now let's see how suitable they are and how possible to implement them into the logical form so that they can be further converted. If a relationship is in 1M, no further refinement is needed. So it means the relationship is in the perfect form if it is in the 1M, all right, one-to-many. This relationship shows that the entities at the many end needs to have a foreign key referencing the primary key of the entity at the other end. So one-to-many means the many end has the foreign key, and one has the primary key which is referred as a foreign key in many. Then there are, so this is the case with the one-to-many. So no further refinement is needed, and it is easy to implement them directly. Then comes the one-to-one relationship. So these are options. There are options for implementation. However, such relationships are extremely rare, and we do not need to consider them here. So one-to-one relationship is extremely rare, where the connection between the two entities, they are only in the state of one-to-one relationship. All right. Now the third one, the problem relationship is the many-to-many. So this is actually the problematic relationship. So where a foreign key cannot be used. Why? Because a foreign key attribute can only have a single value, so it cannot handle the many references required. So another way of looking at this problem is that to argue that a foreign key is required in each entity, but neither table can be created first because the other table need to exist for the foreign key to be defined. So definitely, in order to add a foreign key, there need to have the table whose primary key is called here as a foreign key. So it is not possible to create any of the table if the primary key is not available. So it becomes so much complicated. So the solution for the relationship is to create a link entity. All right. For example, if band and booking, this is one example that we were using. The band and the booking, the logical entity table model would contain the link entity shown in this, like band and booking, they were in many-to-many relationship. And the solution to implement is to break it into, so basically what does this mean? This means if two tables like table A and table B, they are in relationship with each other. All right, there's one more thing before I do give you this example, that in the ERDs, the shapes and the diagram used, this shape is used to represent the entity, and this line shows the relationship, and this crow feet shows many, and if this line shows one. All right, so we'll be using these shapes for the ERDs. So now in this case, what is the problem with one-to-many? So let me again go back and give you the same example. One-to-one is, so this is one-to-one, A and B. This is in the one-to-one relationship, and one-to-many is going to be, this is one. So let's say if this is one-to-many, and many-to-one is one-to-many, and many-to-many will be like this. So basically, this is going to be the representation of one-to-one, one-to-many, many-to-one, and many-to-many. All right. So these are the ERDs representations. So coming back, so what I was saying, that if the two tables like A and B, they are in the relationship of many-to-many. So this is many and this is many. So what is the solution of it? That we create a link table to break the many-to-many relationship. So this many-to-many relationship is going to be broken, and this will be broken by creating a link table between them. So a link table A and B, and this is the link table. Now this is one and this is many, this is one and this is many. This is how, so basically many-to-many is converted into one-to-many and many-to-one. So this is how the ERD give us the solution. All right. So many-to-many is actually a problematic relationship, and it cannot be realistically implemented, and there is a very much complication in it. So the solution is to break it into one-to-many relationship by creating a link table. All right. So I hope it is clear. So the relationship between the student class is many-to-one, as one value of the attribute class ID may appear many times in the student ID, but only once in a class table. In order to speed up a searching of a data, an index can be used. This is the data structure built from one or more columns in a database. So this is the further detail. So I have just explained this ERDs diagram, and this is the shape of the table with its attributes. These are the attributes, and this is the relationship. This is many, this shows many, and this shows one. Okay, and you can see that the student class ID, this is the primary key of the class table, and student ID is the primary key of the student table. When this class ID is used here as a foreign key, so the many relationship, many sign or the crow feet sign will always be there where we will have the foreign key of the other table. All right, now let's come to questions to make this this topic more clear. So now you can see here that the database, in this question you can see that the database design has three tables to store the classes. That, so we will highlight. So we have these three tables, student class and class group. So this is the link table. Primary keys are not shown, so it is not mentioned. There is one-to-many relationship between class and class group. So class and class group has one-to-many relationship. How the relationship is implemented? Now this is the question, and the question has 2 marks. All right. So how this? So basically, we are going to how means you need to tell the reasons. So basically, why the class? Here they're saying that the class and class and class group, the relationship between them is one to many. Why is this? How this relationship is? So we can say that the primary key, the primary key in class is class ID. All right, so this is the primary key. So 2 mark question. And the foreign key of class group is class ID. So this is how, when the primary key of the class is used as a foreign key in the class group, so this is how the relationship is implemented. Describe the relationship between class group and student. Now the sequence is from class group to student. So class group has the foreign key, so it is many to one. So the relationship is many to one. Okay, so this is how the relationship is created. Okay. Now the next question is that the database design has 3 tables to store the qualification. To store the qualification and grades, each student has attained the following. So we have student qualification and student qualification. Now again, this question is, we have 3 tables. One is student, the other is qualification, and the other is student qualification. And this is the primary key, this is the primary key, and you can see here the student key and the qual code. So the primary key, the primary key, and it is here the foreign key, the foreign key. So here, draw an entity relationship diagram to show the relationships between these 3 tables. So it's very simple. Student, so we'll write student here. And then in between we'll use student qualification. And then the third one is just a minute, is qualification. So now the relationships we can show. So this is how the relationship is shown. All right, student qualification and qualification. So basically the group, the link table will come in between. All right, so this is the joint table or the link table, you can call it, and the qualification is on, and the student table is on the sides. State the type of the relationship exists between student and student qualification. Now when we read from student to student qualification, this is one-to-many relationship. All right, this is how the ERDs they are actually shown.